Hello and welcome to my channel. In this video we are going to solve the 29th question from CBSE Class 10 2023-24 additional practice questions for Mathematics Standard with subject code 041 section C, where each question is of 3 marks. Now this question has an OR question as well, that is either you can attempt this one or the other one. We will be solving both the questions in the same video. Now this question is a combination of circles and triangles chapter. So let us start with this one. In the given figure, PQ is the diameter of the circle with center O. R is a point on the boundary of the circle at which a tangent is drawn. A line segment is drawn parallel to PR through O such that it intersects the tangent at S. Show that SQ is a tangent to the circle. Now let us try to understand the question and write down the given points over here. I have already written the solution of this question, so I'll be discussing the answers with you. So here I have written the given points, that is given is PQ is a diameter of the circle and a tangent is drawn at point R. Line segment OS is parallel to PR, so you can see the arrows, which means that PR is parallel to OS, and it is given in the diagram. Now we have to prove that SQ is a tangent to the circle. Now to prove this, we are going to make use of some concepts, and I have listed here few of them. That is, we are going to make use of the isosceles triangle, which is formed within a circle. Then we are going to make use of alternate angles concept of parallel lines, and we are going to use exterior angle property and congruency concept. So let us see how we can use these concepts in solving the example above. I have copied down the same diagram over here for explaining how we are going to connect these concepts to solving the example. Now here let us consider the isosceles triangle POR. Now this is the triangle we are talking about, and why did I call it as an isosceles triangle? The reason is OP, that is this side, is equal to OR, because they both are the radius of the same circle. So if two sides are same, the opposite angles are going to be equal, that is angle P and angle R are going to be same. So if two angles are equal, we call them as isosceles triangles. So since these two sides are same, the angles OPR is equal to angle ORP, as it is written over here, and this is because they are isosceles triangles. The next thing we are going to make use of is the alternate angles concept of parallel lines. So let me show here the alternate angles. The lines drawn in red represents an alternate angle because PR is given parallel to OS. So angle PRO, that is this angle, or ORP as written here, becomes equal to the angle ROS, that is this angle, because of the alternating angles property of parallel lines PR and OS. So till here we have made use of the isosceles triangle and the alternating angles concept. Now let us see how we can use the exterior angle property for the given diagram. So here we have written also angle OPR, that is this angle, plus angle ORP, that is this angle, is equal to the angle QOR, that is this entire angle, that is big angle. Here angle QOR is acting as an exterior angle to the triangle POR, and according to the statement of the exterior angle property, we know that the exterior angle will be equal to sum of opposite interior angles of the given triangle. So here opposite to angle QOR are the interior angles R and P. So QOR becomes equal to the angle OPR and angle ORP. So we have made use of exterior angle property. Next, let us look at angle QOR. So let me highlight here. Now angle QOR is made up of two angles. As we can see, it can be broken up as angle QOS and angle ROS. That is, the total angle is broken down into two angles. So we have written here, and angle QOR is equal to sum of the two angles, that is angle QOS and angle ROS. Now we are going to substitute in place of angle QOR, angle QOS and angle ROS, that is shown over here. Therefore, angle OPR plus angle ORP is equal to QOR is replaced by QOS and ROS as shown. But here we can see that angle ORP is equal to angle ROS. So in place of ORP we can replace ROS, and ORP was also equal to OPR. That means in place of OPR we can also substitute ROS. So you can see here I have substituted in place of OPR ROS, plus in place of ORP I have put again ROS, equal to, the right hand side stays the same, QOS plus ROS. Now we can subtract one ROS and one ROS from both the sides of the equal to sign, and we are left with angle ROS equal to angle QOS, and let us consider this equation as equation 1. So till this point we have made use of the three concepts, that is isosceles triangle, alternating angles and exterior angle property. Now we are going to make use of the last concept, that is congruency concept. So let me come back over here. So I have recopied the same picture. Now here we are going to consider two triangles, that is triangle ROS and triangle QOS. Now let us see what all things we can find in these two triangles, and let's find out if these two triangles are congruent. Now the first thing is, now the side OR from triangle ROS is equal to the side OQ from the triangle OQS, because OR and OQ are the radii of the same circle. So we have written OR is equal to OQ. Next, from equation 1 which we just got, we found out that angle ROS, that is this angle, is equal to angle QOS, that is this angle, that is from 1, using exterior angle property. Finally, we can say that side OS is equal to side OS, because this is a common side in the triangle ROS and QOS. So we write OS is equal to OS, common side for both triangles. So now we can say that the triangle ROS is congruent to triangle QOS. So let us see here. So from SAS, that is side inclusive angle and side criteria, we can say that triangle ROS is congruent to triangle QOS. Now once we have proved this, all the remaining sides and angles become equal to each other, that is by corresponding parts of congruent triangle concept. So here we further write that since SR is a tangent to the circle, it's already given in the question, it makes 90-degree angle with the radius of the circle, that is by using the tangent theorem. And as angle ORS, just now we found out that this is 90 degree, this will be also equal to angle OQS, that is by CPCT. OQS also becomes 90 degree as it is written here. So we can say that SQ is a tangent to the circle, because tangent makes 90-degree angle with radius of any given circle. So this proves that SQ is a tangent. So we made use of four concepts over here, that is isosceles triangle, alternating angles, exterior angle property and congruency of the triangles. And we proved that SQ is a tangent to the given circle. So this concludes the given question. Now let us look at the OR question. Now this is the OR question, and this question also belongs to the circles chapter. So let us start with the question. Shown below is a circle with center O. Tangents are drawn at points A and C such that they intersect at point B. If OA is perpendicular to OC, then show that the quadrilateral OABC is a square. So let us start solving this by writing down the given information first. So the given points are tangents are drawn at points A and C such that they meet at point B. Angle AOC is 90 degrees as given in the diagram, and OA is given perpendicular to OC, that is they both are 90 degrees to each other. Now to prove that quadrilateral OABC, as we can see that this is a quadrilateral, we have to prove that OABC is a square. And to prove that, we are going to make use of certain concepts. So here I am going to use the concept of tangent theorems, angle sum property of a quadrilateral, and properties of a parallelogram. So let us start with the first concept, that is tangent theorems. So here we can make use of two theorems, that is radius tangent theorem and two tangent theorem. Both are related to the tangents. So the first theorem gives a relationship between the radius of the circle and the tangent drawn to the circle. Now it states that angle between a radius and a tangent is always 90 degree. So here we can see that OA is radius of the circle and BAC is a tangent. Tangent is a line which just touches the circle at one point and breezes away. So here angle between a radius and tangent is always 90 degree. And the second theorem is called as a two tangent theorem. It states that length of the tangents drawn from an external point is always equal. Here A acts as an external point or an exterior point which is outside the circle. And if we draw two tangents from the same point, then the lengths of the tangent drawn from this point is going to be same. That means length AB is going to be equal to length AC. So if AB is 5 cm, for example, AC also becomes 5 cm. So let us see how we can use these two theorems to solve the example above. So here I have copied the same diagram as it was given in the question. Now in this diagram, B acts as an external point to the circle through which two tangents are drawn, that is BA and BC. So using the two tangent theorem, we can write that AB, that is this length of the tangent, is equal to BC. Now the next thing is we are going to make use of the radius tangent theorem. So here we can see that OA is a radius and OC is a radius and AB is a tangent and BC is a tangent. That means the radius always makes a 90 degree angle with the tangent. So angle BAO is 90 degree and angle BCO, that is this angle, is also 90 degree. So now in this quadrilateral OABC, we got to know that angle A is 90, angle O is 90 and angle C is 90. So let us make use of the second concept here, that is angle sum property of a quadrilateral, to find out the angle of B. So let us consider the quadrilateral OABC. Now here let us use the angle sum property of the quadrilateral. So I have written here angle BAO plus angle AOC plus angle OCB plus angle ABC is equal to 360 degree. That is, sum of all the angles of the quadrilateral add up to 360 degree. Now substituting here, 90 degree plus 90 degree plus 90 degree plus angle ABC equal to 360. So adding all the three angles, we get it as 270 degree. And let us take 270 degree on the other side of equal to sign, and we will get it as 360 minus 270 is 90 degree. So we have got the angle ABC, that is the final angle, as 90 degree as well. So all the angles are 90 degrees now. So there can be two options here, that is, since all the angles are 90, it can be a square or it can be a rectangle. So at the moment we will consider this as a parallelogram, and we are going to make use of the third concept, that is properties of a parallelogram. So let me write here. So consider OABC as a parallelogram. We know that opposite sides of the parallelogram are equal. So side OA becomes equal to side BC and side OC becomes equal to the side AB. So let us write here OA is equal to BC and OC is equal to AB. That is, opposite sides of a parallelogram are equal. Next, we can say that side OA is equal to side OC because both are the radii of the same circle. So these two sides become equal. So let us write now OA is equal to OC, that is radii of the same circle. Now looking at these three equations, OA is equal to OC, but OA is equal to BC and OC is equal to AB. So now we can write all the sides as OA is equal to BC is equal to OC and is equal to AB. That is by using these three equations. Now we see that the quadrilateral has equal sides and all the angles are 90 degree. So here, since length of all the sides is same and each angle of the parallelogram is 90 degree, we conclude that OABC is a square, not a rectangle. So here we made use of three concepts, that is tangent theorems, angle sum property of a quadrilateral and properties of a parallelogram to prove that OABC is a square. I hope you have understood all the steps and liked the video. If you know any other way of solving this example, do comment below. And if you are liking my videos, like, share and subscribe to my channel. And thank you for watching.